Okay, so this is the continuation of the previous video. Just because it was getting very long, I decided to stop it and continue in this next video. So we just talked about label encoding for our target feature. Um, Next, we're going to do one-hot encoding. So when there is no order, but there are several categories. So like here in the job, there's retired, admin services, technician, blue collar. There's probably a few others that we haven't seen. We would do one-hot encoding. So first, we're going to create a list of the columns that we're going to one-hot encode. So the first one is job. So I'm just going to read them off from here. We have job, we have education, we have default. Yep, that needs to have that. P outcome. Yep, that's it. These are the list of the columns to one-hot encode. And so for each column, I'm just going to look at the unique entries. I needed that when I was writing the code originally, to just look at the entries that they are. And then this is the way to do one-hot encoding. You use the get dummies method in pandas, and like I told you, you come to pandas. I know it is one of the general methods, so not input output, we're looking for general functions. I open that and then I just say get underscore dummies, and here you will see how to use this method, but I'm not going to look at that here. We're going to actually just use it, and this will be your chance to see what one-hot encoding is. Is it? Yes. So what it does, so in the job, let's see. If you look here, the job had retired, admin, services, technician, blue collar, self-employed, management, unemployed, student, entrepreneur, housemaid, unknown. It's going to change this one column into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns, so that if the person was retired, the retired column will be 1, and all the other columns would be 0. So admin will be 0, services will be 0. So, and that's what I do here when I say job admin, job blue collar, job entrepreneur. So this person was, well, this person, for instance, was an admin person. So that admin is 1, and all the other jobs will be 0. And that's why it's called one-hot encoding, because everything will be 0 and only one column will be hot for that particular thing. And so what we've done, just to remember this job admin, whatever, education had education high school, education illiterate. Let's see what else it had. Educational professional course. So like this person had a university degree. So high school is 0, illiterate is 0, professional course is 0, unknown is 0, but university degree is 1. And this is what one-hot encoding is. And what it tells the model is that this person did not have a high school education, was not illiterate, did not do a professional course. Yes, the highest level was university degree, and did not have this. And so this is how we encode categorical data that doesn't have any kind of order. We use one-hot encoding, and this is how to do it. You have the code, you can go and look at it. So now I also decided that, you see, under education there was unknown, under job there was unknown, and a previous outcome there was non-existent. So what I decided is that instead of dropping missing values, so this is a different way of dealing with the missing values. If education is unknown, I'll just set all these to 0. So high school, illiterate, professional course, university degree, whatever. So in this case, unknown would have been 1, but I'm going to drop the unknown column so that everything will be 0, and that will be our signal to the model that we don't have information about education. And so I've done this for all the columns that I did one-hot encoding, and then this was just checks to see that this code had worked. And indeed, it had worked. Did it work? Yes, it worked. Then I dropped the month. The reason why I dropped the month is because I had the month here and I had the encoded month. So the get dummies function that I used here drops. So when it gives you job housemaid. Like when it does the one hot encoding, it drops the original column. But the one that I used to encode the month, I can't remember what it was, does not do that. So after I get the encoded month, I drop the unencoded month. And so that's what I did here. So I dropped the month. And so we only have month encoded. We don't have month anymore. I feel like something is supposed to be missing at this point. Okay, yes. I know. Right. Then we come here. Now, this is something that's very tricky, and I'm sure it's going to happen to some of you. Usually, when you say drop and you don't include this in place equals true, it doesn't actually drop it. It gives you a copy of this data frame with the month dropped. But in the actual data, in the encoded data frame, this month column still exists. So it's something I am sure each one of you is going to face, that when you drop a column, when you try to drop a column, it's important to remember to set in place to true so that it drops it in place. The next thing we're going to do, now notice ages go from, we saw 17 to 98, duration goes from, like, it has huge values, whereas these values only go from 0 to 1. And what this does is it suggests to the model, for instance, that nr.employed is very important because it's a large value, whereas job admin is not as important. So what we're going to do is scale all these values so that they are between 0 and 1. And for that, we use a min-max scaler from sklearn. So we just instantiate it and do the magic and run that. And this is the end of our pre-processing. And now you see all our data looks like it's between 0 and 1. You could do scaled data dot describe. Yeah, let's actually do that. Scaled data dot describe. Is that a function? Yep. So for everything, this is the count. That's 548. The mean is there. The minimum is 0. The maximum is 1. Like, see, for every column, the minimum is 0 and the maximum is 1. And that is the job of scaling. And so that's the end of pre-processing. It's taken a very long time. And this is modeling. I'm going to do very little about modeling because pre-processing, I think, is where a lot of the thinking happens. Modeling is quite easy. These libraries make it very, very easy. So I'm only going to do an SVM, and I showed you a link to where the documentation is. Yeah, you don't just want SVC, not the score method. And I gave you a link to the artificial neural network documentation. You would you would use it very similarly to the way you use the SVM. In fact, most models that sklearn has work, the way they are used is similar to each other. So this would be a good guide. Another note is that sklearn usually calls neural networks multi-layer perceptrons. So be aware of that. So what you do is we take our X is a scaled data without the column that you're predicting. So the Y, whether or not this person signed up. Our Y is that column that we want to predict. And then we use this function train test split, and the test size is 0.25. So we reserve 25% of our data for testing, and we get training, testing. So we split it into X training, X testing, Y training, and Y testing. And then instantiate the SVM. So they call it the support vector classifier. So if you're using the SVM for a classification problem, this is a classification problem, then you would use a support vector classifier. If you're using it for a regression problem, use a support vector regressor. That's a hint because you will use MLP classifier and not an MLP regressor. And for any other model you would want for this, you guys are not going to be doing this problem. You'll do another problem. So note whether it is a classifier or a regressor. So if you're choosing yes, no, or just between a few classes, that's classification. Class And if it is a continuous variable, so how long is it going to take? 1 minute, 1.5, 1.6. So if it could 3, 7, 15, 15.2, then that's a regression problem because your predicted variable is continuous. Okay, so we use the linear kernel. There's a few types of kernels that are available, and if we go here and look at the documentation and check the kernels, so we have the linear kernel, polynomial, RBF, sigmoid, and pre-computed kernel. Your GCU learn on one of the weeks where we talked about SVMs would explain to you what a kernel is. It doesn't go into much detail, and you don't need to know much detail. Um, this is the main thing that you would probably be tweaking in the SVM. And then we fit. So this fit function is the training. So we give it the X and Y training data, and then we test the accuracy and see how it performs. So we run it here. Reach end of file while parsing. So we have an error. Okay, so I really have no idea. So let's x drop access equals columns. Is it possible? It's not possible to pause the recording, so I'll have to do this live. Equals straight split xy to size there. That SV kernel equals linear fit extra y train. See, oh, here it is. So this print function does not have a closing bracket. And so let's just look at that. We are waiting for it to run. It is taking time to train, give us results. Any second now. Yeah, I don't want to edit the video and have to cut this, so I'm going to ask you to be patient. Maybe instead I could show my face and smile. Oops, or not. So our accuracy is 0.8668, about 86.7%. Now, at this point, you want to change. This is one way, the average accuracy. So this means that for the training data that we had, 87% of the time, our model got it correct. We could, another thing we could do is, what is another thing we could do? We could now make some changes. There are many other ways to test, and those are things that I have mentioned down here. We could use a different kernel. So I remember one of the other kernels was RBF, and use the RBF kernel and try that. See what. So remember, for that other one, we had an accuracy of about 86.7%. This time we have. We're going to have to wait. Yeah, I could now show my face. Boom. Yeah, there we are. Hello, everybody. Yep, so we're just going to see. Hopefully, you're going to finish today. I guess this is also a good teachable moment to show you how the RBF kernel is more complex than the linear kernel. And that's why the training takes slightly longer. It is 86.6%. So it's quite similar performance to the linear kernel, but it takes longer to train. So you would pick the linear kernel because they both perform the same, but this one trains quicker. So there are many other things that you could try and change. See the effect on the accuracy. I've given you suggestions of further things you could do. So check the effects of various things. So we did balancing. You could fail to do balancing or do undersampling only or oversampling only and see the effect on the accuracy. Could check the effect of scaling. So don't scale and then see what happens. Use a different kind of scaling. So there's a scaler called the standard scaler, which instead of scaling from 0 to 1, scales from -1 to 1 and makes sure that the mean is 0 and the standard deviation is 1. Use other metrics for testing accuracy instead of for testing performance. So instead of the accuracy, you could use something called a confusion matrix. And I've included a link to the metrics that sklearn offers. And finally, you could try other models other than, well, of course, you have to do neural networks. You could try the random forest regressor, XGBoost, etc. That's it. This thing has become really, really long, but I hope you see how we have done acquisition, exploration, preprocessing, and creation of a model, and just reasoned through various things about the data at each point. This has become really long. I hope it is helpful. The links are in the notebook. A link to the notebook is going to be in the description. Thank you very much in the description below. All right, cheers. Bye.